Hey guys, Jessica Sullens here, and today we are going to talk about Module 5, Chapter 7, Decimals, Real Numbers, and Proportional Reasoning. Now, I finally am getting my voice back, so I apologize if I sound funny or if it starts going in and out, but we're going to get through it today. Okay, our first problem from our homework says, convert these decimals as fractions in lowest terms and demonstrate how to find the prime factorization of the denominator in each use. The first thing we're going to start with today is looking at number 1, and our number is 0.225. So since we're working to the right of this decimal, those are not actually whole numbers. They can be looked at as fractions. So what we need to do is write this out in expanded form so it's a little bit easier for us to read. So what we would do is put our fractions, our 2 is in the tenths place, tenths with a th at the end because it's not actually a whole number, so it's not a 10, it's a tenth, it's a part of it. So, and we do not start with a ones place because of this decimal, we always start with the tenths. So going back here, we're 2 over 10, so 2 tenths, 2 over 100, so 2 hundredths. We have 5 over 1,000, so, and then that's going to add up to equal 225 over 1,000. Well, that's a pretty large fraction, and we definitely can simplify that down a little bit. So what we're going to do is think of a number that goes into both of these. Well, looking at these, we automatically know that 25 goes into both of these numbers. So what we're going to do is divide 25 into 225 and 25 into 1,000, and we're going to get 9 over 40. Since we use that 25, we're going to say that 25 is our greatest common divisor and gives us 25. Now, if you wanted to check your work, all you have to do is divide 9 into 40, and then that's going to give you the 0.225. So that's the best way to check your work and kind of know where you're at. Make sure that you have the right number, the right fraction. So over here, we're going to look, and we've got 0.036. So we're going to take and do the same thing as we did over here and put that into our fractions. Now, you do not have to use the 0 over 10. I simply choose to so I can keep up with where I'm at, and so I don't accidentally put this 3 over a 10. It's just kind of a placeholder, just so it's easy to see. It's a visual to know where you're at. So we're going to do 0 tenths, 3 hundredths, 6 thousandths, remember the th at the end, thousandths, and that's going to equal 36 over 1,000. Well, let's think about what goes into 36 and 1,000. We're kind of limited on numbers here because 36 is so much smaller than this 1,000. But we do know that 4 goes into 36, so let's take and do that one first. So 4 goes into 36 9 times, and luckily 4 goes into 1,000 250 times. So that would make 4 our greatest common divisor. And remember, you can check your work by dividing the 9 by the 250, and you would get 0.036 in your calculator. So let's look at our prime factorization over here. Before we simplified, our new denominator right here was 1,000. So I went ahead and did 1,000 since it was the same for both problems. And I simplified this down to 110, so it makes 1,000. Over here with 10, we can simplify that down even more, and we get 2 and 5. Excuse me. Over here, we do our 100, and we get 10 and 10. And then we simplify those down even more, and we get the 2, 5, 2, 5. So let's count these up. How many 2's do we have? We have 1, 2, 3. So we're going to do 2 to the third power up here, times, and we're going to do our next number, which is 5, and then 5, or 1, 2, 3. So we have 5 to the third power. So these are in simplest form, so we can say 2 to the third power times 5 to the third power is the prime factorization of 1,000. All right, question 2. Kate promised Zoe that she would share her M&Ms with her. They would split them up 50-50. How many M&Ms would each of the 2 girls receive? Well, what we're looking at over here is this problem right here. We're trying to figure out y, and y would be how many M&Ms each girl receives, and then our x would be the number of M&Ms we start with. So Kate could have any number of M&Ms. She might have 5, she might have 20, she might have 30. But we're going to keep it simple today and do, say she had 6 M&Ms. So we would plug this 6 into our x. So simplifying this down, 6 over 2 would be 3. So y would equal 3. Let's check our graph. 6 M&Ms total, how many she started with. Going across, where does it meet? At 3. Okay, so yes, it does check out. So each girl would receive 3 M&Ms. If she had 10 M&Ms, we would put the 10 right here for x, and then we would say x or 10 over 2. And if we simplify that down, our y would equal 5. And we can see that's where they meet on the chart. All right, if we have another problem, this one almost looks the same, but you can see this negative right here. So our other chart was a positive, it was going up. This one is going to be a negative, so it's actually going down. So what we are going to do is look at our decreasing chart, and if Kate gave Zoe half of her M&Ms, how many M&Ms would Zoe have left? Well, what we're going to do is plug in how many she has to start with. Remember, that's our x. And then the y will be how many she has left. Excuse me. Okay, so let's say that she has 4 M&Ms. So we have our 4, be our negative 4 right here for x, over 2, and that is going to equal 2. So she would have 2 M&Ms left. We can see that's where it meets because she lost 2, so she has 2 left. She had 8 M&Ms, 8 over 2, remember a negative, and that would divide down, and our y would equal 4. So she would have 4 M&Ms left. Okay, going over here, we are looking at this right here, y equals 10x. Well, our x is going to be our dollars, and our y would be how many we have. So how many dimes we have. So if we had, say we had $3, so we would put this 3 right here for x. 10 times 3 would be 30. So our number of dimes we have would be 30. And you can see this is where the x and y meet on our chart. Say we had $5. We would put our 5 right here, 10 times 5, and that would give us 50 dimes. And we can see right here, that's where it meets. So this is how our chart would be. Money is pretty easy to think about when we're doing this because we know something we deal with all the time is money. Okay. All right. Over here, we are looking at y equals x squared. So we want to know what y is, but it is always equal to whatever x squared is. Whatever number is squared equals y. So this chart shows a point or a number point on the axis. If we look at the point where it meets the y-axis, we can see what number is squared. So let's look at 2 squared. This is a simple one. So we start with 2, square it, we get 4. Pretty easy. We have, let's go down here, we have 4 and we square it. We go all the way up, we get 16. So that's how we would do that. And this is an easy chart to look at and see what's squared. And we can see our chart is going up. So it's an increasing chart. Keep going. Okay. What we're going to do here with these 3 shapes is demonstrate the percentage and fraction of each striped area for the first 2 figures and the pink area for the 3rd figure. So we have 3 different shapes here, and you can see that this one is broken into 4 equal areas. This one has 1, 2, 3 by 3, so that would be 9 equal areas. And this one is 2 equal areas. First, we're going to start with this square right here. So let's go over here. we're going to talk about the percentage and fraction that is a striped area. We had four areas at first, but we only had half of this shaded over here. So what I did is added these white lines, and we are making it a larger area. We started with 4, but since half was shaded, we wanted to make equal parts to make this a little bit easier to work with. So we can look and see that we are looking for a numerator and a denominator to make the fraction. Well, you kind of think, what does that have to do with this? Let me show you. Just how you want. So our numerator is how many of the whole, and our denominator is how many make the whole. The easiest way to think about this. So what we're going to do is look at how many pieces we have now. And we had 1, 2, 3, 4, 5, 6, 7, and 8. So how many make the whole? It's going to be 8. And then we have one of those areas shaded. So our fraction would actually be 1 over 8. And if we divide this into our calculator, we would have 1 over 8, or 12.5% of this area is shaded. Try next one. So we're doing the same thing over here. But if you look, we have this one spot that is shaded, and it doesn't, add up to a whole square. So this would be kind of tough to work with. And we don't want decimals in our fraction at all. We want to keep it simple today. So what we are going to do, since we started with 9 squares, I'm actually going to add lines into each one. And by adding these, we are actually doubling how many squares we have. So we know there are 18 in all now because we started at 9. 9 times 2 is 18. So we want to know, or we're going to put our 18 in our denominator, but we need to know what to put in our numerator. So what parts are shaded? Well, simply we can count these and see that 1, 2, 3, 4, 5, 6, and then this little one up here will be 7. And that would give us 7 over 18. If we put that into our calculator, it would be 38.9%, because 7 divided by 18 would be the 0.389, and we just take and move our decimal over 2 places. I apologize. All right, with this one we are doing, demonstrate the percentage of the fraction of the pink area. So over here, this one's very simple. You have 2 equal areas, and we know that this would be 50%. This would be 50% to make the whole 100%. So what this would be is 1/2. So 1 over 2, because we had 2 areas. So our numerator is 1, our denominator is 2, because the whole equals 2. Or 50% make up the pink area right here. All right, number 4. The area of the yellow hexagon is the whole. The remaining pattern blocks have areas that are 16.67%, 19.2%, 33.3%, 38.5%, and then 50%. How many of each shape fit into the hexagon? So this is pretty simple. If you were in class, say you had some cutouts of those little shapes, the little wooden shapes, or if you had your students cut out the shapes and fit them in with paper, they can glue them for maybe the younger age group. But what we're going to do first is look at our triangle. So we can see that this is the same shape as here. And if it goes in, it would kind of fit pretty much like a piece of pizza. But we know that 6 triangles would fit to make this whole. So it would be 1, 2, 3, 4, 5, 6. So this one shape right here is 1/6 of this hexagon. So if we divide 1 into 6, it would be 16.67%. Our next one right here is our little diamond. So, and it would take and go into here 5 times, because you could do 1, and then do another one, 2, 3, and then our remaining will be half here, and then half here, and half here. So 1 over 5, if we divide that, it would be 19.2%. Over here, our rhombus, we can take and fit this in, and we know that it would be 1/3. This one shape is 1/3 of this hexagon. So if we divide that out, it would be 33.3%. And our square would be 38.5%. And then our trapezoid right here can take and be 1, flip it over, mirror it, and then it would be 2, so it would be 1/2 or 50% of this yellow hexagon. Okay. Moving on to number 5. Find the percent given A and B. What percent of B is A? So what we're going to do is, I made up this word problem. Molly has 4 pairs of the same shoe. She decides to downsize and gives 2 pairs of her shoes to her younger sister, Jasmine. What percent of Molly's shoes went to Jasmine? Well, we know that Molly had 4 pairs of shoes over here. She had 4 pairs of the exact same shoes. So we can see her shoes here. So she's downsizing and she's giving 2 of her pairs of shoes away to her younger sister. So shoes that went to Jasmine were 2. Looking at this, you can see that we took away half. So 50% are which of Molly's shoes went to Jasmine. So we would do 2 over 4. We had 4 starting out, so 4 goes in our numerator or denominator. And then our numerator was 2. So 2 over 4, 50% is the easiest way to look at this. 50% of Molly's shoes went to Jasmine. Okay. For our next one, find the part given a percent and the whole B. What is A if the percent of B? If it is the percent of B. So what we're going to do is Molly has 4 pairs of the same shoes, and her sister Jasmine asked if she could have 25% of the pairs of shoes she had. How many pairs of shoes went to Jasmine? Well, we have 4, and we're looking at 25%. So this is the easiest way to talk about this is when you think of money. We all know 4 quarters go in to make $1, and quarters are worth 25%. Or I'm not sorry, 25 cents. So, but 25% of $1. So if we give Jasmine 25%, we are giving her 1. So we are left with 3 right here. We gave her 1. So 25% or 1 pair of Molly's shoes went to Jasmine, because this would be like 1 quarter versus our 4 quarters for $1 to make 1 whole dollar. There we go. Find the whole given a part A that is the percent of the whole B. What is the whole B? Jasmine received 2 pairs or 50% of Molly's shoes. How many pairs of shoes did Molly start with? Well, we can think about this as 2 pairs. So we have 2, and we have to put it over something else. We need a denominator down there to know what the whole was. So if we knew it was 50%, we can simply times that by 2. So we can do 2 times 2 to make our whole, which would be 4, because we would add 1 more, or you could think of this as the money. So right here we would have 75%. We could add 1 more and have our whole, which would be 100%, because if this was 2 pairs, 50%, you could have done 25, 25, 25, 25. So we can see that Molly started with 4 pairs of shoes. Okay. Moving on, we had to create a proportional reasoning scenario, then create a table and a graph to show the rate of proportional change. So let's look at this. Let's say Jessica runs 1 mile in 10 minutes. How long would it take for her to run 4 miles? So we can take and just assume that Jessica keeps that same 10-minute a mile pace the whole time and doesn't fall or have any other encounters that might slow her down. So what we're going to do is create a chart. So we know she ran 1 mile in 10 minutes. So we would put our distance ran 1, and this is in miles, for her time, which is 10 minutes. So if we go over here, if she ran 1 mile in 10 minutes, we could say, okay, she ran 2 miles. We're going to double this. She ran 2 miles in 20 minutes. So we could say 3 miles, she went in 30 minutes because we're doing another 10 minutes increments. 4 miles in 40 minutes, and then 5 miles would have been in 50 minutes. So, and then we were trying to figure out how long it would take for her to run 4 miles total. Let's look back at our chart and we can see our miles ran 4, and it goes all the way over here and look at our time, which was 40 minutes. We also had to create a graph to show the proportional change. So let's go to our next slide to look at our graph. And here we have miles per 10 minutes. In the bottom down here, it shows along our x-axis number of miles ran, and our y-axis shows our time in minutes. Our chart is increasing because every mile she runs, we're adding another 10 minutes to it, so it's actually going up. Just a second. More quite that. So you can see if she ran 1 mile 10 minutes, and then 2 miles in 20 minutes, 3 miles in 30 minutes, and so on and so on. We were looking for the 4 miles, so 4 miles in 40 minutes, and she would run 6 miles in 60 minutes. So this is a very simple way to see, these numbers and see how they relate to each one. So that was all of our video. Thank you very much for watching. I hope you learned something, and I hope it helped explain our homework a little bit better.